if we go to 33, this is just continuing. If I were to ask you, so we started talking about normal CDF and inverse norm. And so basically, the challenge is to know when to use which function and what to enter, right? What are the entries that I'm supposed to put in? Now, you might prove me wrong. You might be like, nah, I got this, Mr. Dirksen. I don't need more help. If you're in that boat, you're, okay, fine. I can deal with that problem. I'm going to deal with the problem of maybe you're not so sure yet what to do, or how to punch this in. So if you listen carefully, I'm going to do it one more time, and then I'll give you some time to work through this yourselves, okay? So if it says 45% of households earn more than a certain amount, right? So technically, we want a dollar amount there. You should know if it gives you the probability or the percentage, you're not using normal CDF, you're using inverse norm. Okay, that's what you're using. Now you have to figure out what should I enter there. Guess what, folks? The mean and the standard deviation is a given. So that one, I hope at least that one you would know to type that in. But it's this part that is critical, okay? So you need to read it. 45% of households earn more than this X value. So you need to figure out along this curve, and this is just, I'm not usually going to give you this. You can quickly make one of these yourselves. But you need to know that if you were in the middle, 50 would earn more, 50% would earn less. And we know that the middle is 45,000, so that's kind of pointless. If 45% of this income make more than this value, you're kind of assuming that it's going to be somewhere in here. And how do you know? Well, you can tell that 45% would go here, right? There's less. If you think of 100%, there's 45% here. And this is going to allow you to figure out this side. Okay, so you go 100 minus 45, and so that's 55% that goes here. That is the one that inverse norm needs to get this right. Okay, that is the one we want. So we put that in as a decimal. There it is, and you type that in. You know how to do that, right? Remember how to do that? Clear second vars, inverse norm, 0.55, 45,000, and 15,000. And there it is. So this is an actual dollar amount in this case. So that's 46,884.92. All right? Make sense? It's not a percentage. You already know the percentage. Don't use normal CDF. That's when it's inverse norm time. Okay? All right, so we got that. Let's do page 34 because there's a few that I haven't really covered. So maybe you're not so sure how to do those. So let's go to 34. You maybe you have drawn this curve already, perhaps. But here it is. So you can't say I didn't go over this again, right? So here we go. Potato chips come in a bag with a mean of 250 grams, a standard deviation of 5. The weights of the bags follow a normal distribution. What does that mean, folks? A bell curve. That's what that means. Okay? So whatever you do, go to the middle and then split it up into 3 equally spaced out sections like that. And that was nice enough. So this is my mean here. And then we go 3 standard deviations to the right. Mr. Dirksen, why is it 3? Why is it 3? Why is it not 4 or 5 or 6? Because after 3, it's so little. The percentage of data being in there is so little that we kind of say 3 is enough. Because if you have 3 to either side, that's 6 standard deviations, correct, guys? And these 6 standard deviations have 99.7% of the data in it. So you're dealing with a little bit of a tail on either end, right? So we don't bother going more than 3. That's why. Go to the top. And I've seen some of your bell curves. You kind of like outdone me, and that's not fair. It took me years to perfect the art of bell curving, okay? But that's okay, I'll take that. So there we go, and then you split this, and this is for reference only in this case, reference only. And I kind of don't like what I'm doing here. I should have been using a ruler, but it is what it is. And these are estimated values, okay? These are not exact. It's a bit of a model that we, but this is a good review on how to do a bell curve. So I would expect you to have the percentages. I would expect you to have some values down here. In this case, they're pretty straightforward. You just go up by 5 and then you go down by 5. Boom, you got that. And then along the x-axis, you will have the weight in grams, okay? Weight in grams. Bingo, you've got 2 marks if you have all of that. So 1 mark for this, 1 mark for the percentages, and then you would lose marks if you don't have your labels there. So here we go. Calculate, I do tell you to use technology, okay? So don't be using this if I ask you to use technology. Calculate the probability, percentage, they mean the same thing. Folks, this is important. There's a chance, a 35% chance that a bag will weigh between 245 and 50. That's what this percentage is also saying. It's a probability, likelihood, okay? So when you see probability, don't freak out. That's literally what we're trying to find here. That's what the percentages represent. So calculate the percentage of bags weighing between 232 and 273. When it's percentage that you're asked to find, you want to use Inormalcdf. And in this case, who was I helping yesterday? Anyways, Clark, I think, right? Oh, I shouldn't have said. Start, stop. Think of start, stop. Like your start is 232, your stop is 273. So you're telling inverse norm, start calculating from 232 all the way to 273. Give me that percentage. And I almost wanted to put down 45,000 because I've done that so many times. What's the mean here? It's 250, yeah. There's a couple of hints. This, right? You go back to the question. So anyways, there we go. So you get a decimal when you do that. 99.98%, right? Does that make sense? Second verse, 232, 273, 250, and 5. Yeah, so that's 0.99983, so all of that. And most of the time, if you're going to use this to figure out the actual number of bags, in this case, use all of this, okay? Don't round. And don't forget your percentage. If you do multiply that by 100, you have to have a percent sign, okay? I don't know if I did this on my key. I will do this here with you. Okay, pay close attention to this. What are the z-scores? Remember what z-scores are? Z-scores, if you have a normal curve already graphed, we usually label the ones that are obvious. Okay, 1, 2, 3, -1, -2, -3. So these are z-scores. Did you know that you could use z-scores instead of the actual weight? And you're like, I don't really care, Mr. Dixon, because just feed me the notes, okay? I'll worry about that later. I hear you. But I want to show you that you could use z-scores instead of the actual weights, okay? So please write this down. It's going to be a little tight. It's going to be tight here, but I think we can do it. Do you remember how to find the z-scores? Z is x minus x bar over standard deviation, correct? That's on your study sheet, I hope. So watch this. 232 grams has a z-score of, we're going to figure that out, 232. 273 grams has a z-score of, we will figure that out. And it's going to be tight, I know that. I'm going to zoom into that part so you can write it down properly. You can see it, right? So let's calculate the z-score for 232. It would be 232 minus 250 over 5. We'll figure that out in a bit. For 273, the z-score will be 273 minus 250 divided by 5. Can you see that? I hope so. See, when my teachers were on me to have neat writing, I should have listened to them. Never listened to them. Saying, it's just for me, right? Now it bites me. I've improved greatly, though. This is, if you had me 10 years ago, you would probably drop this course by now. I can't read a thing. Anyway, so if we do this one, I'll just give you the answer for now. That gives you negative 3.6. Mr. Dirksen, negative 3.6. How's that possible? It is. It's just way out here somewhere. Way out here. The z-score for 273, if you calculate that, you get 4.6. Say what? 4.6, is that possible? Yes, it is. Again, this is just what we usually graph, but you could have more standard deviations to the right, more to the left. Okay, now, this is the cool part. Write down normal CDF. And instead of using the weights, we're going to use these values. Negative 3.6, 4.6, and here's the million-dollar question. What do I put down for mean and standard deviation? What's the mean and the standard deviation if I'm talking z-scores? 0 and 1. Okay? So your mean is 0, your standard deviation is 1. If you go 250 and 5, it's going to be off. Okay? So you got to make sure this is your mean and this is the standard deviation in this case because we're talking z-scores. Let's try that. Hopefully you get the same answer, right? Or else this all goes down the drain. Hey, got the same answer. 0.9998 ... which is 99.98%. Why would you bother doing this? I think I just want you to know that that is a possibility. Because sometimes all I will give you is z-scores. You should be able to use normal CDF still. However, you're just going to put in z-scores, but you need to know you're not going to use the actual mean and the actual standard deviation. If it's mentioned, you're going to use 0, you're going to use 1. Okay? That is the only caveat there with using z-scores is you must, I will highlight this whole thing. This whole thing, just saying this is an option here. This whole area here that I've added is kind of like an optional step that you could have taken. And I know what you're saying. It's way too much work. Why would I do that? I agree with you. I just need you to see that both of them are possible. Okay. All right, keep going. Calculate the percentage of bags heavier, greater, more than. You want to heavier, that's what it means. It's like everything heavier than this. So if you want to have a little bell curve here on the side, okay, where is 256 according to our graph? This is the mean, right? It's a little bit off here. It would be somewhere in there. So you just kind of tell yourself, this is 257 here. And what am I finding? Everything to the left or to the right? To the right. I'm interested in this. This is more heavier. So that means that you will go normal CDF. And this is where students are like, This is your low, your start. 257 is your low value, your lower limit. Okay? And what's your upper limit? It's infinity. But guess what? If you put in infinity, your calculator would never stop calculating. It would just keep going till infinity. You don't want to sit that long, do you? No, I wouldn't either. So you just put down 1,000,000 or something really big, okay? And then followed by, is it 0 or 01 or is it 255? It's 255 because this 257 represents an actual weight, okay? So let's go ahead and figure this out. Normal CDF 257, 1,000,000. Mr. Dixon, would 100,000 work? Yes. Why do you go 1,000,000? Because sometimes you're going to have to go millions. I'll say it this way. If I give you, if your values here were in millions, okay, how many families make more than $1 million? Let's say I just asked you, how many families make more than $1 million a year? Would you put your upper limit at 1,000,000? You should go 10 million, 100 million, right? So it is basically dependent on the context. But 1,000,000 works 99.7% of the time, okay? So I'm just going to multiply this by 100. 8.08%. That's what that, if you want to get a full marks here, you round this number that you multiply by 100 to 2 decimals. Okay? That's how you do it. Next, calculate the percent of bags weighing less than 243. Is this normal CDF? Calculate the percentage of bags, normal CDF. Okay? Normal CDF. I know that for sure. Some of you might not need this anymore, what I'm doing on the side here. But weighing less than 243.5. We're going to use this as our reference. Where's 243? It's somewhere here to the left of the mean, right? So if I draw my bell curve, it's somewhere in here. That's 243.5. It says weighing less, correct? So which side of the curve am I trying to find in terms of percentages? Left. This is what I want, okay? So what is the 243.5? Is that a start or a stop? It is my stop. It is my upper limit. So I need to go negative 1,000,000. I know if you look at my key, I probably don't always use 1,000,000. It doesn't matter. Okay. None of my lessons are the same. If you take this course again next semester, I'll be like, you know what, there's a better way of explaining this. And so I try to constantly change and kind of read my students and see how I can do a better job, right? So you type in this. I'm just going to go and get it again. So negative 1,000,000, 243.5, 255. Make sure your commas are there. That's 0.0968. That's actually rounded to 4 decimals right there, or 9.68% if you want it as a percentage. So this, the area or the probability under the curve of a bag weighing less than this, there's almost a 10% chance of that happening. Okay? Okay, the company, this one is tricky. This one is worth 2 marks. You want to put 2 marks beside this one? This one is going to hurt you if you don't know what to do. going to hurt you more than the others. A company disposes of any bags weighing less than this, okay? So bags weighing less than this, so this is one aspect of it, and any bags weighing more than 262 grams. So these are discarded, okay? I want you to graph this here with me on the side, because this one is actually trickier. So anything less than 239, it doesn't matter, this is not to scale, but imagine this is 239 here. So anything here is discarded, this is gone. They're probably gonna just open the bags and put them back in the mix and repackage them so that they weigh the proper amount. And then more than 262, so let's imagine 262 is here. Okay, so any bags weighing more than that are also gonna be discarded of. So we want to find the combination of this, both of these combined. But so you have a choice here. I'm going to go with the one that you're probably going to be able to wrap your head around best. Okay? I'm going to do a normal CDF for this tail here. If I want this tail, how would I enter this into the calculator? What would I start with? Negative a million. Yes, all the way to 239, and I know my average and I know my standard deviation. I'll come up with a number. Oh, I should have gone with different colors on the tails here, and I could have highlighted, but anyways. Plus another normal CDF. Now we're going to deal with this tail here. So what do I start my entries with? Start, right? It starts at 262 and it goes to infinity. So we're going to go 1 million. 255. So you enter both of those and here's what you get. 139, 1.39%. You know what? I will actually do this with you and just go with all decimals first. Sorry about that. I'm just going to use this one and change it to 239. Just change this to 239.0, right? That fixes that. So this is 0.0139, keeps going. Now I have to do this part right here. Fun stuff, eh? On a Friday. You have a weird definition of fun. Watch this one. This one is even smaller. Okay, there we go. So you add this up. And I have this on my calculator, right? I can go copy paste plus copy paste. That is 0.0221. Okay, combined. Which is the equivalent of 2.21%. Okay, so there's a different way of doing this. Let's cut this right here. This is option 2. I need you to know both, okay? I need you to understand both of these. I'm going to do a normal CDF. You know what? Can I change this? Sorry. I hope you have a pencil for this one. What's the area under the entire curve? The probability. It is 100% or 1, right? So watch what I'm going to do. I'm going to go 1 minus normal CDF of 239 to 262. Say what? 1 minus normal CDF. So I'm going to take away this middle section. It's not really the middle, but you know what I'm saying. Right? This non-highlighted section. I'm going to take that away from 1, and that's going to leave me with the tails. So this is another way of doing that exact same question. I think it's more efficient, to be honest. So I'm going to go ahead and do this. Second. That is 0.99778, and that keeps going. So I'm going to go 1 minus on my calculator, copy, paste, and that is 0.0221. And that translates to 2.21%. So regardless of how you did it, you get the same answer. I don't really care how you do it, but I think it's nice for your brain to see it both ways, right? So you kind of understand the concept a bit better. Fun stuff, hey? Let's keep going. 35. I'm taking my time for a reason, because I want you to really understand this, not just copy paste. Okay? Backside. This is continued from the previous page, this one right here. If the company produces 5,400 bags per day, how many bags would be removed from the production line? I'm going to go 5,400 bags times 0.0221. That is from my previous page. I just figured out percentage-wise how much I'm going to remove. Now I know I can figure out number of bags. And that would give me 119.34, which is approximately 120 bags. Probably safer as a company to say we're going to remove 120 bags. Okay, I'm going to go a little bit faster now, okay? Morning. What percentage of bags have a weight with a z-score between negative 0.6 and 1.34? Is normal CDF, right? Because it's asking for what percentage, what probability. And I have z-scores, correct? What do I put for mean and standard deviation? I'm going to go thinking bubble, okay? Mean is 0, standard deviation is 1. Okay, immediately. You want to know another cool secret? I don't know if I should tell you this, but because you might by mistake. If you were to omit the last 2 entries, normal CDF by default would assume that it's 0, 1. By default, it would, oh, you're using z-scores. It would know right away you're using z-scores. So if it doesn't get anything for these 2 entries, it will assume it's 0, 1. It's going to bite me, I know. You're going to just constantly not put it in, and then we're in trouble. But anyways, why not give you some secrets, right? You know how they told you, you can't take the square root of a negative number? You know how we used to tell you that all along? It's actually a lie. We should have said, you can't do it yet. Right? That's what we should have said to you. If you multiply this by 100, I'm going to go comma, 63.56% of bags. How much can you handle today? I don't know how much information. Can I just cut this right here? Maybe just copy this part. Could we have figured out the actual weight that goes with negative 0.6 and the actual weight that goes with this, and then use normal CDF differently? The answer is yes. So a z-score of negative 0.6 actually has a score, remember? you got to use this formula. Negative 0.6 times the mean. No, sorry. What's the formula again? Z-score. Z-score times standard deviation. Sorry. Z-score times standard deviation, which is 5, plus the mean. Sorry, and that's going to give us a number here. We're going to put it right next. A Z-score of 1.34 has an actual weight of 1.34 times standard deviation plus 250. Do I have this on my key? I do. A negative 0.6 Z-score is the same thing as saying 247 grams. And it makes sense, it's below the average, right? Which is Z-score was kind of giving away. It's a negative. And this one will be above the average by 1.34 standard deviations. So this is going to give you, sorry, I'm trying to find my notes here, 256.7. And now I'm going to use Inormalcdf using these two, 247, 256.7, 255. And I'm just going to tell you that this is 63.56. You're just going to trust me, take my word for it. It's the same answer. Same answer. Oh, man. Sorry, I added this to your booklet. All of this was supposed to happen in here. Sorry. I should have. I didn't see it on my old notes. It doesn't have that part, but there you have it. I want to get to inverse norm. Here we go. G is starting with inverse norm. The company would like to know the weight. Know the weight. Okay? So it's asking, like, what is the weight that would place 65% of bags produced below this weight? I can tell you already it's going to be inverse norm. I can tell you already that there's going to be 250 and there's going to be 5. We just have to figure out as a decimal the percentage to the left of the curve. Draw your curve, please, on these ones. It'll make your life so much easier. 65% of bags produced are below this weight. So try to think with me here. Where would it be? Or are they giving me to the left of the value? And the answer is yes, because it's below this weight. Okay? So it's safe to assume that the value in question is somewhere in here where you have most of it below you, 65%. So this would be 35. Do we care about the 35? No, we don't. Okay? This is not really relevant. This is the one we want. So we put the 0.65 in here. You always have to ask yourself, is the percentage that I'm given, is it below the value in question? And yes, it is. So here we go. You got to go second trace, inverse norm, no, not second trace, second vars, 0.65, 255. It's 251.93 grams is a bag that weighs that much. Here's something cool. I'm going off on a tangent a lot. Could you use inverse norm to find the z-score? Write this down, z-score. Remember I gave you a formula to figure out the z-score? Yes, it's possible. But you could also use inverse norm, 0.65. What's going to go in here? 0, 1. Let's figure that out. 0, 1. So that's the z-score. 0.39. This is an aside like that. This is really what we're after. But sometimes you can use inverse norm to figure out the z-score if you have the mean and the standard deviation. So the company would like to know at what weight would 6% of the bags produced be heavier than it? If you, I know what you're saying. This is so confusing. Why is the wording so funny? Okay. But remember, they want to know the weight along the x where 6% of bags are heavier than it. If you put it here, would that be accurate? Don't copy this. Is that accurate? Would you be able to say this is 6%? No, this is wrong. Okay. So you know, if 6% of bags are heavier than it, it has to be somewhere in here. Because then you could say, yeah, that kind of makes sense. That's 6%. Is this the entry that inverse norm needs? No. You need this one right here, 94. So saying that 6% of bags are heavier is the same thing as saying 94% are lower than it or way less than it. So inverse norm, 0.94 to 55. I'll tell you this. If this question is worth 2 marks, if the question like this is 2 marks, it probably means that I give you the right side, you have to find the left side, that'll be worth 1 mark, and then another mark for you using inverse norm. So that's another kind of giveaway. I'll just give you this answer. That is 257.77 grams. And I want to do the middle one yet, yeah. Okay. Determine the z-score of a bag that's heavier than 55% of the bags produced. A z-score of a bag that is heavier than 55% of the bags produced. You want the z-score, and this bag with that z-score is heavier than 55% of the bags produced. Does that make sense? So it is to the left, right? Inverse norm, 0.55. You want the z-score, right? So can I just use 0, 1? Yes. Mr. Dirksen, why don't I use the z-score formula? Why can't I use the z-score formula? Let's do this first, and then I'll explain that one. This is 0.13. And it makes sense, because this puts you slightly above the average. The average is where 50 is left and 50 is right. You're slightly over to the right, not by much. I will just make a note here. Note, can't use, can't use this one. I do know my mean, I do know the standard deviation, but I don't actually know the x value, okay? So that's why I don't know this, unknown. That's why I cannot use this formula. So sometimes you'll just try it and be like, yeah, I can't, I'm stuck. And because I give you the percentage, you should know, oh, this is probably inverse norm, right? When I give you percentage, it's inverse norm. That's another hint that gives that one away. We're almost done, guys. Just go through 36, and then I'll give you another task after this. Determine the z-score of a bag that is lighter than 31% of the bags produced. The z-score of a bag that is lighter than 31% of the bags produced. Where would you put this? lighter than 31%. So this bag with this z-score is lighter than 31% of the bags produced. So you want this z-score right here, because the 31%, right, this one is lighter than 31% of the bags produced. So that's why it's actually giving you the right side in this case. And we're going to figure out the left side. 69%. So inverse norm. 0.69255. And I'm just going to have to take my word for it. This is 0.5 is your, sorry. You see the mistake? I made a mistake. This would be a -1. I want the z-score correct. So what does this have to be? 0 and 1. Right? Because when I'm asking for z-score, you should be thinking the mean is 0, the standard deviation is 1. So this is wrong. My bad. And the answer is 0.5. There's a long way about finding the z-score. You could have gone 255. That would have given you the actual weight. And then you could have used the formula to convert that into a z-score. But why would you want to do more work, right? We're all about doing less work, being as efficient as possible. Determine the z-score of a bag weighing this many grams. No percentage, right? So this is simply using this one. So that's 259.25 minus 250 over 5. And that's 1.85. Meaning of this thing, a weight of 259.25 grams places the bag at 1.85 standard deviations above or below the mean. And the answer is above, because it's positive, the mean. That's what that, if I ever ask you for the meaning of what you just found, this is what that means. You can use your own words, as long as you tell me that it represents a number of standard deviations, either above or below the mean. The key word here is above and the number of standard deviations. And here's the last thing that I'm going to do today, and I need you to practice this. Okay, this one right here. COVID symptoms last 7 days on average. You can tell when I made this booklet, right? It was lonely basement days, where I was talking to everybody via Google Meet. Standard deviation of 0.5 days. So 7 days is the average. Standard deviation is 0.5. If the duration of the symptoms is normally distributed, determine the middle 80% of the cases, right? So it says, basically fill in this statement, the middle 80% of cases last between X and X number of days. How would you do that? You're awake for this one, right? This is my grand finale here. If it says the middle 80%, you can actually say, go to your curve and say this is 80%. And we're going to call this X1, and this is going to be X2. So this question wants you to put X1 in here and X2 in there. How would you do this? If 80% is taken, folks, what are these two sections going to add up to? 20%. Okay. So we're going to go 100 minus 80. That's left with, that leaves us with 20%. We divide this by 2 to get 10%. Why? Because 10% goes in there and another 10% goes in there. Let's do that together. 10%, 10%. How could I find x1? Percentage to the left is given, right, for this one. So I'm going to use inverse norm of 0.1. The average is 7. The standard deviation is 0.5. What about x2? What percentage is to the left of x2? 80 plus 10. So 90%, correct? Do 2 inverse norms. I'm just going to try to highlight this because right, this 10% here went in there. And then I'm going to try to do the 90 like this, just outlining it. So this is 6.34 days. And this is 7.64 days. And days is continuous, right? Actually, you can get partial days. You could turn that into hours if you wanted to. Which one is 3/6? This one? I'm just going to take your word for it. I just want to make sure I got this right. Second trace, 0.1, 7, 0.5. Yeah, it's 3/6. Thank you. 3/6. So 80% of the middle 80% of cases last between 6.36 and 7.64 days. That's why they kept on saying flattening the curve, flattening the curve. They were talking about a normal distribution. And COVID cases were so normally distributed, like the number of days it took you to get over it was very much normally distributed. Where some people took 2 weeks, some people were like a couple days they were feeling better, right? But most of us had 7 days, right, of symptoms, most. And then it varies as you go to either end. All right. Let me just see here. What is the best? I'm